Welcome to my e-lecture series. In this video, you will learn on the experimental errors and selected statistics used in analytical chemistry. First thing that you need to know is about the measurement and readings of the apparatus used in analytical chemistry. They depend on what apparatus or instrument you used or read. For example, 50 milliliter burette with 0.1 graduation, the readings must be to the nearest 0.01 milliliter. Calibrated millimeter ruler, the readings must be to the nearest 0.1 millimeter. Can you guess the readings of analytical balance, top loading balance, and pH meter? Measurement is the base of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Error is the difference between the true value and the measured value of a quantity. There are two types of errors known as systematic error and random error. Systematic error is always too high or too low. The example of systematic error is improper shielding and grounding of an instrument or error in the preparation of standards. Random errors are those errors which occur irregularly and hence are random with respect to sign and size. This can arise due to random and unpredictable fluctuation in experimental conditions such as unpredictable fluctuation in temperature, voltage supply, mechanical vibration of the experimental setups, and personal errors by the observer taking readings, etc. For example, when the same person repeats the same observation, it is very likely that he may get different readings every time. If your measurement and readings are high in precision, you are able to control the random error. And if you have high accuracy, then you are able to control the systematic error. Systematic error can be further classified into instrumental errors, method errors of imperfection in experimental technique and procedure, and personal errors. Instrumental errors arise from the errors due to imperfect design or calibration of the measuring instrument, zero error in instrument, etc. Method errors occur when you determine the temperature of a human body. A thermometer is placed under the armpit, which always gives a temperature lower than the actual value of the body temperature. Other external conditions such as changes in humidity, temperature, wind velocity, etc. during the experiment may systematically affect the measurement. While personal errors arise due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precaution, etc. In analytical chemistry, you should expect how to graph and interpret data found from your experiment. You will also use this graph to help you find missing information. In fact, a lot of your lab will require you to determine several unknowns. So let's review the anatomy of a graph. There are two axes, the x-axis, which is horizontal, and the y-axis, which is vertical. The x-axis is known as the independent variable because this is the variable you are able to control in an experiment, while the y-axis is known as the dependent variable because its change is dependent on the independent variable. For example, if we have absorbance as our dependent variable and concentration as the independent variable, and as we increase the concentration of a substance, the absorbance also increases as it is dependent on the concentration of the substance. The majority of your graph will be linear, and you will notice that your data points wouldn't perfectly align to form a perfect line. This is why we use something known as the best fit line, which is a straight line that best approximates the given set of data points. This line may pass through some of the points, none of the points, or all of the points. go over the exercise for better understanding. Table below shows the data for calorimetric determination of glucose in syrup. By using the least square method, determine the concentration of unknown 1 and unknown 2 solutions. Least square method involves the y equal mx plus c equation, where m refers to the slope and c refers to the y-intercept. The y-intercept is a point found on the y-axis. The slope is the change of y over the change of x. The slope is very useful because it will help you determine any unknown values. To find the slope, start choosing 2 points. The first point is x1 and y1, and the second point is x2 and y2. Then plug in the label values into the formula and subtract first, then divide to get the slope. So in this case, the slope is equal to 0.070. To find the unknown 1 and 2, insert the absorbance value into the y equal mx plus c equation you obtained just now. The glucose concentration for unknown 1 is 4.9 millimolar and the unknown 2 is 9.4 millimolar. Alright, for next exercise, okay, you are given a series of standard cadmium solution prepared, okay, using this range of concentration, and the absorption is measured using the atomic absorption spectrophotometry, AAS, one of the instrument that we have to detect sample that we have. So the original cadmium sample is diluted 50 times and the following data are obtained. You are required to plot a graph and determine the concentration of the unknown X, okay, here, and its concentration in the sample. Okay. So the important information given in this question is that the original cadmium sample is diluted 50 times. Okay. So you may highlight or bold the information given, and then you are asked to plot a graph. Okay. Previously, you can find the concentration using the least square method. But now, you need to plot graph first and then determine the concentration of unknown. Okay. 1. Need to determine the concentration of unknown. And its concentration in the sample. Okay, so you need to find 2 concentration. First, the unknown. Okay, here, the value of X. And also, its concentration in the sample. Remember, the first information that we have, it is diluted 50 times. Okay, so the original one, you need to calculate. Okay, how to do it? First, we are going to plot the graph. Okay, there are 2 ways to plot the graph. Okay, if you are asked to plot a graph using graph paper manually, okay, or you are asked to plot graph using Excel. Okay, depends on the requirement. Usually, when you do the experiment in lab, so for your lab report, you can provide graph using Excel. But in the examination, you are given graph paper, then you need to show how you plot the graph using the graph paper. Okay. Okay, now I'm going to show you how to plot using Excel first. Okay. So first you need to copy the given concentration and absorbance. Okay. And then paste in your Excel. Okay. Right. Then to plot the graph, you need to go to Insert tab up here. Okay, and then choose type of graph that you want. So in this case, we are going to use the scatter chart type. Okay, and then we have this x-axis and y-axis. Okay, so I recommend you to choose layout 10. Okay, if you are using a Windows 10. Okay, why? Because you can easily see the scale on the graph, so that when you want to find the unknown on the x-axis, you can easily look at the scale and predict the value. All right. Okay, and then when we have this point, okay, we need to have the straight line. So how to insert the straight line? You click on the point, okay, and then right click, okay, you will have this option. Then click on add straight line. So now you have the straight line here. Okay, you can see on your right hand side, you can choose a suitable option that you need. Okay, in this case, we need a linear straight line, and then we also need the equation. Okay, so we know that this is y equal to mx plus c. Okay, so I don't need this information, so I'm going to delete the information. Remember that you need to have axis title. Okay, so on x-axis, okay, you can get the information here. It is concentration in microgram per mil. So don't forget to write the title together with the unit. And on the y-axis, it is absorbent in absorbent unit. Okay, so write down the concentration and its unit microgram. So please use the correct symbol. Don't use U. Okay. It is microgram per mil. And then on the y-axis, okay, it is absorbance. This one we get from the AAS. Okay. So another missing information is the graph title. So insert the graph title. Chart title. Okay, so it is concentration versus absorbance. Okay. So now you have chart. Okay, you already plot the graph, and I'm going to copy this one. Okay, we can paste here. Okay. So next requirement is you need to determine the concentration of unknown using this graph. How to determine the unknown using graph? Okay, if previously it is least square method, you can use this equation y equal to mx plus c. But now it requires you to determine the concentration using the graph. So first we need to look at the value, the absorbance given for x. It is 0.479. Okay. So go to the y-axis on your graph. Okay. Then you need to have this straight line. Okay, insert shape, you can use this arrow. Okay, we have 0.4 to 0.5, so it might be around, we have 5 scale here. Okay, each scale is 0.02, so it is a bit below of the 0.48 here. So insert your arrow just now. Okay, point it from the y-axis. Okay, and then put the arrow from y-axis straight away to the straight line. Okay, and then from here insert another arrow to get the value on x-axis. Okay, so it will start right away at the end of the first arrow. Okay, then you can put it on the x-axis. Here. So now we know that the value of x is in between 4 microgram per mil to 5 microgram per mil. Okay, and the value of the scale given is around 0.2. So you have 4, 4.2, 4.4, 4.6. Okay, it is around 4.5859. Okay, so that is how you determine the concentration of X using graph. Okay. You need to show this arrow, then you can get marked. If you don't show the arrow, okay, you didn't fulfill the requirement of the question. Okay, so we can say that the X value, okay, is equal to 4.6 plus minus 0.01. Okay, so any value given in this range are correct. Okay, so don't forget your unit, which is microgram per mil. If you left the unit, then you will not get marked. Okay. Now you already have the concentration of unknown X, but we need to find the concentration of the unknown in the sample because the original sample has been diluted 50 times. So this concentration needs to times 50. It will be around, okay, it is around 230 plus minus 0.5 microgram per mil. So this is the answer for exercise 2. Okay, and this one is using the Excel. As for plotting the graph using graph paper, you may do it as exercises. Please scan the QR code for your attendance. Basic statistics in analytical chemistry. Basic statistics involve the mean, deviation, range, variance, standard deviation, relative standard deviation, and confidence interval that you can find by inserting the value into the given equation. For easy understanding, here is the example. For the data given, you need to calculate the mean, median, standard deviation, variance, relative standard deviation, and range. Give full attention on how to insert the value into the equation. First is the mean. We know that mean is equal to the total of all the values given divided by the number of value given. So in this case, you will get mean is equal to 0.749. The decimal places is based on the question given. In this exercise, the highest decimal places given is 3. Thus, your final answer should be in 3 decimal places. Next is median. Median is the middle value. First, you need to rearrange the value from the lowest to the highest, which are 0.725, followed by 0.751, 0.752, 0.756, and the largest is 0.760. So median is the one in the middle, which is 0.752. Next is standard deviation. To find the standard deviation, you need to insert all the values given in the equation, where xi is the value given, minus the mean, square, and you need to find the total of all the value given. Divide by number of value and minus 1. Don't forget the square root, then you will get 0.014. For variance, you need to use the equation given, insert the deviation value, square, divided by n minus 1. We know that deviation equation is xi minus mean. Then you will get 1.898 times 10 to the power of negative 4. Relative standard deviation. Relative standard deviation is equal to standard deviation divided by mean. Then you will get 0.019. And the last one is range. Range is equal to the highest value minus the lowest value, where we have 0.760 minus 0.725, and the range is 0.035. Application of statistics to data evaluation. The purpose of applying the statistics to data evaluation are to reject the outliers, to define the confidence interval, to determine number of replicate measurement required, to estimate the probability that an experimental mean and true value are different or that two experiments are different, and lastly, to treat the calibration data. Here are two common tests used to evaluate data in analytical chemistry, including Q-test and T-test. Q-test is used to reject outliers. Outliers are extremely high or extremely low value in your data. We can identify an outlier by using Q experimental equal gap over range equation. The value should be rejected if Q experimental is greater than Q table, while t-test is used to compare measured result with a known value, compare replicate measurement in an experiment, and compare individual differences. We can conclude that the measured value is different from the known value if the T experimental is greater than T table. These are the values of Q for rejection of data using Q-test, while this table shows the value of students T for T-test. You don't have to memorize all the values because the table will be given in the appendix of assessments. To understand better on those statistical tests, please look at the example for each of tests in the given separate videos. That's all for chapter 3. See you in the next video. Bye-bye.